Good afternoon, everyone. Thanks for coming to this session. My name is Bodong from uCRobotics. In this session, I will talk about indoor predation with IVY5661 96Boards. Here's the agenda today. I will give a brief introduction about uCRobotics and general introduction about IVY5661. And we will talk about indoor predation solution on IVY5661 and the use cases, and the last is demos. First, who is uCRobotics? uCRobotics is a high-tech company focused on intelligent platform system integration and development of embedded system. Actually, we are located in Beijing, China, and there will be three keywords of uCRobotics. First one, intelligent platform. uCRobotics is the manufacturer of Bubblegum 96, which is the fourth commercial edition 96 boards. And we also manufactured O2 and Blue Sky. They are IoT boards, and now we moved to IVY5661. And the next keyword is solution. We have 3D cloud printing solution, robotic solution, and big data solution. And the third keyword will be open source. We have much contributions on open source projects such as OpenStack, Docker, and Linux kernel. So what is IVY5661? Actually, it's a IoT edition 96 board powered by UniSoC connectivity SoC UWP5661. And it was announced on the last Connect in Vancouver. And here's a spec of 5661. It uses UniSoC UWP5661 SoC, which contains the CPU ARM Cortex-M4 CPU, and the clock frequency will be 416 megahertz. Storage will be 32 megabit, and for the RF part, we support IEEE 802.11ac and Bluetooth 5. And as IE spec, we have expansion interfaces which support UART, I2C, SPI, I2S, GPIO, and the operating system on this board is Zephyr. So what can we use? Which part we can use on IVY5661? First, we can use use it as a Wi-Fi repeater, which we have demoed on the last Connect. You can connect the board with your smartphone and configure. You can connect the board with your smartphone through Bluetooth and configure the board to link the non-Wi-Fi router, the access point, and set the password, set the SSID, and just click the start button. It will broadcast the Wi-Fi signal for the other smart devices. The Bluetooth mesh. Bluetooth mesh networking enables many-to-many devices communications, and it optimized for creating large-scale device networks. It is ideally suited for building automation, sensor network, search tracking, and other IoT solutions that requires tens, hundreds, or thousands of devices to communicate with one another. And we are now using it as the solution of indoor predation. With UniSoC SoC inside and Zephyr deployed, IVY can be used as an intelligent household IP camera, Wi-Fi repeater, and we use Wi-Fi on IVY to make indoor predation happen. So here's a Siri. In this system, IVY board is used as AP access point or the station. So when we get the when we know the distance between access point and station, we can calculate the right position of the station. How do we get the distance between station and access point? We use RTT protocol. So you can use a Wi-Fi location functionality provided by Wi-Fi RTT API to mention the distance to nearby RTT capable Wi-Fi access point and peer Wi-Fi aware devices. When in a two-dimension system, the surface, you need at least three access points to locate the right position of the station. So if you mention the distance to 3 or more access points, you can use a multi-iteration algorithm to estimate the device position. And we should notice that the result of RTT protocol typically accurate within 1 to 2 meters. Here's a theory. When you get the distance between RTT and access point, that means the station will be on the circle of this distance. And when you get the 3 distance, there will be 3 circles, and there will be only one and only one coincidence point. So when you know the coordinate of AP1, AP2, and AP3, you can use this function to calculate the coordinate of station. Here is the code how we can use this function. First, we need to calculate the coordinates. We need to calculate the coincidence points of 2 circles and lines and line, and the station will be on this line. And next we calculate another 2 circle, and the station will be on another line, and 2 lines, there will be only 1 coincidence point, that's the coordinate of the station. So what we haven't done yet is we need to support 3-dimension position. We have to provide space position to implement the position with different floor. It means for now, we will not know if we are on the same floor or on the top floor or on the down floor. So we have to provide space position. And next thing we have to do is deploy with access points wall and redundant ranging data processing. And we have to improve the ranging data accuracy. I think there will be 2 ways. We can use the Bluetooth RSS position as a reference, or we can smooth the location data. So with the IVY5661 indoor position solution, it will be easy to deploy, and it will be low cost. Where can we use on the where can we use this solution? We can use it on the shopping mall. Users want to know where is a shop is, where is a restroom is, where is the restaurant is, and also we can use in the airport or train station. Actually, it is now used in the industrial line in Vostok. Another way we can use indoor predation solution is robotics. Actually, uCRobotics have the robotics solution, but we use depth image based VSLAM to predation. It works well in the small area, but it failed to localization in large area. For example, the airport. The scenes in the airport will be quite similar. So VSLAM is not good in such scenes. So we can use IVY5661 indoor predation system to navigate between two big scenes, and then we use VSLAM to navigate accurately in a specific area. Here's a demo. Actually, at the beginning of this session, I have deployed 3 access points, 1, 2, and 3. So this is a station, and it will get the distance between station and these 3 access points, and it will calculate in the PC. Okay, this is the UART log. You will see RTT will send the MAC address and the range back to station, and the station will get the number of the range. First, we need to import the coordinate of at least 3 access point. See, they are on PC. It get the data from the station through UART, and it will calculate the coordinate of the station. You can see the red point is the position of this station, but you know, there will be 1 or 2 meters for the RTT protocol, so the point is jumping actually. But if you move this system to a big scene like 100 meter or 200 meter, the 1 or 2 meter will be small. Here's all my session. Any question?
You said that the IV boards were low cost to deploy. Can you say exactly, like, ballpark retail price, what they are?
It's $39 US for each board. I mean, most of the product in the market for indoor predation will be expensive, like Cisco or something. It will be expensive, but use IVY, it will be cheaper, much cheaper. Any question? Yeah.
For the three-dimensional support, will that three-dimensional support, once it's available, will that run on the exact same hardware, or will that require different hardware?
I think it's on the same hardware, but we need at least 4 access point, and the coordinate of the access point will be X, Y, and Z also.
Okay, you'll be able to achieve that with the same deployment that you use today, or do you have to vary the deployment of nodes in the Z range? Like, if you have these ones on the floor, do you have to move some of them up in order to achieve the 3D?
I think the equipment is the same, but we need to change the code or their algorithm maybe.
Okay, now one more question related to that. Is that code remotely updatable? Can you deploy that over the air?
Not now, but maybe soon in on GitHub maybe.
Okay, thank you.
Yeah, I think I saw you were running a Zephyr stack
Yes.
on the board. Which Bluetooth or Wi-Fi drivers are those things you wrote or somebody else wrote?
Yeah, it's wrote by UniSoC. Maybe Gong here can explain this.
And are those Wi-Fi and Bluetooth drivers open or closed?
Hello. Hello. Hey.
可以的吧？
Those Wi-Fi and Bluetooth driver are open, and we are doing the upstream work currently. Yeah. And it's powered by UniSoC. Thanks.
Yeah, and there is some work on the common Wi-Fi manager being upstreamed by Keguang. So they are upstreamed yet into the Zephyr project. So this is on the review.
Regarding the OT update, it's actually possible to do the remote update actually over the air because their Zephyr support is their Zephyr support actually incorporated MCU boot, which means that we can do the over the update through Wi-Fi or Bluetooth. Yeah.
Any question? Okay, thank you.